Kia ora Year 11 and 12. Here's a little proof of our result about the sum of the roots of a quadratic and the product of the roots of a quadratic. So in the last video that I put up tonight, we had two examples in which we saw this pattern, but we didn't do a general proof. So what we want to do now is to look at how we can show that it holds for all quadratics. So this is my equation. Let's try and get the pointer working. Right, so this is the quadratic in expanded form, and we've found that it's got two roots. Right, so what we're going to do now is show these results. So what does it mean to say that the equation's got two roots? Well, we know that the equation can be written in this form, but if it's got two roots, it can also be written in factorized form. And if the first term is a, we could divide all of it through, take out a as a common factor, and then say, here's one root, and here's the other root. Now, if you don't like that, let's just quickly go back to the last example, where we had 2x squared minus 11x minus 21 equals 0. Now, we factorised that, and we got this 2x, what do we have, 2x plus 3, that's right, and then x minus 7 equals 0. When you're doing this proof though, it's easier to first take out a common factor of 2. So let's see what will happen when we do that. Well, we're going to have 2 times x squared minus 11 over 2x minus 21. Now, that looks awful, except, minus 21 over 2, that equals 0. But we know that here we found the two roots, and the roots were negative 3 over 2 and 7. Okay, so instead of writing it in this form, we could also write it like this. 2 times x plus 3 over 2 times x minus 7. Right, and you can see that all I've done is I've taken out a factor of 2 here. So I've written the 2x plus 3 in this form here. So what we're saying up the top here, going back up to this bit, is that if I know the roots are alpha and beta, I can take out the a, just as I took out the 2 down here, and then do my factorising. So if we want to prove our result about the sum and product of the roots, all we have to do now is to expand this and then match it up with the coefficients up here. I'm going to do that on the next slide. Try and do that first though, before you watch. So just work out what happens when you expand out this expression. Let's have a look. Okay, so we know we can write this expression as a times x minus alpha times x minus beta equals 0. So we've got a times x squared minus alpha x minus beta x plus alpha beta equals 0. So that. Alright, now let's just simplify that. So collect up like terms. And we've got a. Remember, this is a. This is not alpha. This is a times x squared minus alpha plus beta x plus alpha beta. So that equals 0. But I know that this quadratic is the same as this quadratic. That's the whole point, right? We're looking at the two different ways. So what can I say now? Well, if I take this equation here and I expand it out, I'm going to get this. Ax squared minus a times alpha plus beta x plus a alpha beta equals 0. Right, so now I'm going to match up coefficients. These two coefficients must be the same. These two must be the same. And these two must be the same. Right, so a equals a is nothing interesting, but here we've got b equals negative a times alpha plus beta, which gives me the result that I'm after. I get b over negative a equals alpha plus beta. And as we've discussed in class, conventionally, we don't leave the negative number in the denominator. So we get alpha plus beta is equal to negative b over a. Now I'm just going to have room to squeeze in the last result. Please don't have your maths book looking like this, but this is what we get. We get c equals a, that's an a times alpha beta. So this gives me the result that the product of the roots is equal to c over a. And if you look back at the easy video, the first one, this was the pattern that I found. Okay, so really, really useful, as we'll see in the next couple of days. The sum of the roots is equal to negative b over a, and the product of the roots is equal to alpha times beta. If you're doing level 2 NCEA, you don't get given those formulae. You need to know them, and you won't have to use them for any questions. There'll always be another way to solve them, but when you're doing some of the excellence algebra questions, these results come in really, really useful. Alright, thanks for watching. If you found that really hard going, you might want to just try and work through it once more.